All right, so as we take a look at our lesson for today, we're just going to talk about some vocab that we're going to be using for the first module here, okay? So we're all on the same page moving forward with our constructions. So the first one is a point. Now, a point is just a location in space. So it doesn't have any length or width or dimensions. So a location has neither length nor width. Okay, and we name the point using the letter that's located next to the little period symbol there. Okay, so we put a dot, put a letter, and that would be point Q. Okay, so far so good. All right. Now, a line is an infinite number of points. So an infinite set of points that extend indefinitely in two directions. A line has no thickness, so it has no width, just length. And if you give me any 2 points, I can draw exactly one line that can be drawn through those 2 points. And we're going to name this line. Now, this line can be called a whole bunch of things, okay? You can name a line by using at least 2 points on it. You can use 3 or more, and you can also use the little cursive letter at the end of the line. So I could call this line L, with a little cursive lowercase l at the end. I could also just look and pick any 2 points and call it those 2 points. So I could call it point line AC. Now, if I put an AC down and I want to call it line AC, I also need to add a little line hat, right? So you need to put on top of it, do that little double arrow line symbol above it so we know that it's line AC. You can also reverse those letters. Flip it and reverse it. You Missy Elliott fans out there. All right? Anybody? I'll have to play that later. All right? You can also change letters. You can pick 2 other ones. You could pick Ethan. CB, we can call it CB, or we could flip it and say BC, as long as we put that little line symbol over the top. That is acceptable. And we can also use in any order the 3 points on there, so we can call this line CBA, or BCA, or ACB. Those are all the same name for that line, okay? Any one of those things is fine. All right, Janaya, collinear means points that are on the same. Linear means? What's the word you see inside of collinear? I won't underline all of it this time. They're on the same line. So the picture we're drawing is the same one from over there. And we'll just pick 3 letters. We'll pick, how about JHO for our answerer of the day. All right? And that would be line. So those 3 points, JH and O, are collinear because they're all on the same line. Okay. Next term is called a plane. So we can't draw a plane because a plane technically goes on forever. So it's a flat surface like your desktop or the floor, okay, or the wall. Those are all examples of planes, all right? It's a flat surface made up of points that extend, we could say forever or infinitely. We'll just say forever. In all directions. Okay. There is exactly one plane that you can draw through any 3 non-collinear. Collinear, E-A-R there at the end. Points. Points of the same plane are called, get this, on the same line are called collinear. On the same plane are called Instead of linear, planar. Right? Coplanar. Okay. How do we name a plane? Options. Okay. Not 2, but 3. And the 3 points, I'll tell you what we can't use. We can't call this plane DEF. Why can't we call it DEF? Salimata? Yeah, they're on the line. It could be line DEF. So we can't use collinear. So we could call this plane what? Plane. How about DE? Now, is P a point? No, so DEZ. We also could call it plane. Repeat that again, Elliot. Emmett, do it again. Plane. Say the letter. Nope. What was the letter you said last time? P. We could call it just a single letter shown by itself. That's not a point. So we could also call this plane P, because P is not a point. It's just a letter that's on the plane. We can also refer to that as our name. And then the other thing we can do is we could switch up these letters. So we could call it plane instead of DEZ, maybe we'll call it ZED. Or we could flip it up and call it, let's say, EZF, right? Or EFZ. As long as the 3 points you're using are not on the same line and you're changing the order, it doesn't matter. Okay? Or the single letter that's not a point. All right. The intersection of 2 or more geometric figures is the set of points they have in common. So far, so good? Now, 2 lines are going to intersect at a point. A line and a plane are also going to intersect at a point. Any idea what 2 planes intersect at? Think about like this wall and that wall. When they meet, that's not what we're talking about. What? What's another word for a side of a shape? What geometric shape that we've mentioned before would be like a side? A line, very good. So 2 planes intersect. If you didn't say that, we'd look surprised. It was a line. And you can kind of get the idea of what this might look like. If we draw a rectangle like this, so that would be one plane. And I'm going to draw another plane coming out of it. So we'll draw it going this way. And you can see where this would intersect right here. That would be the line where they cross. Okay, so 2 planes meet at a line. Now a corner, right, would be like, if you just look at the lines on the top of the ceiling, those 3 lines meet at that point. Corner is a point, okay? And usually what we would do is like extend this through, and then where this would hit, we would draw like a dotted line for lines we can't see. Okay? That's essentially what that would look like. So 2 planes meet at a line. Don't really need to know that, but just something to throw out there. All right, a line segment is the measurable part of a line consisting of 2 points or endpoints, and all of the points in between them. Either between or in between, your call. All right, the notation. Let's say we add a point on here and call it. So we could call this, first of all, we have to use the endpoints because it tells us where to start and end. So I could call this AB, or flip it and call it BA. Now, question, is this a line segment that I just named? What needs to be associated with this so we know it's a segment? Yeah, you don't actually need the dots. You can just do just a little hat on it with the line. As long as I don't see the arrowheads, I know that you're referring to a segment. You can put the dots if you want. Okay? And if there's a third dot in the middle, which we call Z, right? You can also use the 3 letters, but it has to start, Salimana? Good, it's got to have endpoints at the beginning and end of it. So you could call it AZB, right? Or BZA. As long as Z's in the middle there, we know what we're talking about, okay? Unlike a line, that matters. All right, the length of a segment. The length of segment AB is the distance from A to B. It is denoted as either AB with nothing on top of it, no hat. That means the length of segment AB. Or you might see it written as DIST and then the 2 letters. The module sometimes uses this notation for distance of AB. You might also see like absolute value bars, but it's the same thing. Anytime you don't see anything on top of it, that means the length of the segment, okay? Remember, it's the numerical measurement. So when I put a hat on top of the letters, that means it's the line I can physically draw, okay? That is a line segment. That is a distance. How long is it when you actually measure, okay? One's a number, one's the actual physical segment. It's like a toothpick you could pick up, okay? So if the length of AB as we look at it would be, BC is, and then, now, this ability to add these together, we sometimes call the addition property, or segment addition. You'll see in the box below this one, they call it the property of betweenness, or the parallel partition postulate. We'd like to call it segment addition. I think it makes more sense to say it this way, so you remember that you're adding segments, okay? Usually, though, the partition part just means that they have to be collinear. So point M is between points P and Q if and only if, right? The points are collinear. So the first example, if we know that PM is 6 and MQ is 4, we know that PQ is, why did I put a Q on there? I will never know. Okay? And the saying for this is that the whole is equal to the sum of its parts. Nothing too crazy, right? Okay. Array. It's a part of a line, but it has one endpoint and goes forever in everyone's favorite band. All right, look at that. Sadie is inside, right? So it's got one endpoint and extends away from the endpoint in a given direction. Okay, couple options for names. Kendall, if I want to name this ray up here, it has to start with what letter? A, because that's where the ray begins, that's the endpoint, right? And it has to have another letter that it goes through on its journey. So we would say this is ray A, B, and then I also need to indicate it with the symbol over the top. You guys remember the symbol? That's an arrow pointing one way, and the arrowhead is going to be over which letter? Go for it, Juliet. The B, very good. So the arrowhead has to be over the B. It's got to be facing that way. So it tells us we're going from A through B in that direction only. If we decide to switch these letters around, what do we have to do in order to keep it as ray AB? You got it. Switch the direction of the arrowhead. You can also name this AC okay, as well. Or ABC if you want, is also fine. All right? So Iftikhar, what would you call this ray down here? Okay, I could call it CBA with an arrowhead. Good. Pointing. Mine would be pointing to the right, correct? From C through. Good. Or you could call it CA, right? Or CB, or BC, but then the arrowhead's got to flip. You'd still pronounce this ray CB, though, even though it's written in the opposite order, okay? So just be careful. All right. A figure, I'm going to get too caught up on that, is just a set of points in a plane. So if you can draw me any shape you want, right? So pick a shape, Trenia. Square it is. I'm estimating my square. No matter what shape you draw me, I can draw a rectangle around it, which means that that rectangle is contained in a plane. Your sheet of paper is a plane, right? Except it doesn't go on forever. So any shape is always, any figure is always contained in a plane. All right? Remember, non-collinear points are in that plane. Geometric construction. A set of instructions for drawing points, lines, circles, figures in the planes. Constructions are drawn with a pencil, okay? A compass, which just draws circles, and a straight edge. Completely warning. The straight edge is not a measuring tool. You're not using it to measure the distance between two things. You're just drawing a straight line with it. That's it. Okay? So I know we're picking up rulers. We're not allowed to actually measure something. We have to be able to draw a circle to get where we want to go. Okay? Does this make sense to you guys? So on the test quizzes, grade assignments, whatever we're doing, I have to see your compass mark, the pencil mark from your compass to get points. Okay? Does this make sense so far? The good news. How long have people been doing constructions? Literally since ancient Greece. This OG, the original geometrist, Mr. Davis Joe online, Euclid came up with, right, the rules for geometry, and he was doing those things then, talking about circles and shapes. So there's YouTube videos online for anything you want to do. You literally go to YouTube and say, construction, name what you want to do, it pops up, okay? So if you ever need help, you always have YouTube available for it. We're going to skip these two. We're going to come back to it for right now, page 10, because I don't want to be doing just vocab today. We'll finish it up for tomorrow. All right. Today is construction introduction. So what we're going to do is draw some shapes using only a pair of compasses. You might see compasses online rather than compass, so you know it's not the directional tool, but the geometric tool. A straight edge or a ruler. So we're not allowed to measure any lengths. The word construction in geometry is a very specific meaning we're drawing geometric items, lines, and circles using just a compass and a straight edge. All right? No uses of protractors, so no measuring angles with that little half moon type shape. That's where a protractor measures the angles. And we're not allowed to measure length with a ruler. So the first thing we're going to do is we are going to construct a line segment congruent to AB. All the directions you need are right there. So, step one, you guys ready? We need to know how long AB is. We're not allowed to use a ruler, so we can use our, don't have a protractor, compass, right? And I can open the compass to a certain length so that it is telling me exactly how long, okay, my compass is. Now, when we talk about the compass, we're going to call it a few things. This little guy right here, we like to call it the sharp point. So if you hear me say sharp point, I'm referring to the pointy part here. 2, this is called a pencil. Okay, all right. And when we say open your compass, we just mean you're changing the length of some amount. Now, if you have one of these at home, these will sometimes get loose. Okay, meaning that this groove right here gets a little bit loose. Do have a screwdriver on the table right there, orange. All you have to do is it's a Phillips head. That's what a Phillips head is. It's like a plus sign. Just tighten it up a little bit. If you're at home and you have one of these and it starts moving on its own, just get a Phillips head in there and you can just tighten it up. All right. Good news, Caitlin. It's your birthday. All right. So what we're going to do next is we are going to take our compass. We're going to open the compass and measure the length of AD with it. So go ahead and do that now. So I'm going to take my compass. I'm going to place the sharp point on A. Right, Juliet? I'm going to place my pencil over at B. Now, how are you going to make errors when you're using your compass? Number one, your sharp point isn't on exactly the point you want. Your pencil might not be exactly where you want it. Or as you're making your circle, it might move a little bit. So just be careful. Now, when I'm actually using the compass and I'm making a circle, so tips and tricks. I hold this part right here like I would a pen or pencil. And all you have to do is then rotate by just spinning my fingers here a little bit, okay? Okay? Number two, if I want to turn it and go clockwise, okay? All I'm going to do is lean the compass in the direction I want to go. So if I want to make a circle going this way, I'm going to lean my compass in that direction and then turn my fingers and spin. Okay? If I want to go the other direction, I'm going to lean that way and turn my compass and spin. Option number three, you might have to clear up the dust for this. I can just put my compass down, lean it, and then turn my paper. This is a really easy way to do the construction as well. Okay? Now, every time I want to draw an arc, do I need to draw a whole circle? No. I might only need to see that much of the circle, a little bit of it. You can just make what's called an arc there, a little itty bitty part of the circle. But we understand that little arc represents the whole thing, okay? So, first thing I'm going to do is measure the distance from AB. Sharp point on, pencil on. Does it matter if my compass is flipped the other way? No. And then what I might do for myself is draw a little arc, okay? This arc is part of this, you broke it, this crazy circle, but I don't need all of it. I just need that portion right there, okay? So I know the circle's there, but I'm not using it. Second thing I'm going to do, I'm going to take my straight edge, my compass, my ruler, okay? And I'm going to draw just a line segment off to the side. Now, if I know that I want to copy AB, make sure that your line segment is bigger than the one you want to copy, okay? So far, so good? Where am I going to put my compass point now? The sharp point. Yeah, on the end point. So move your sharp point over to the end point right here. We on it? Started so far? We measured AB. We made a little arc or a circle. We drew a ray off to the side. Sharp points on the end point of the ray. And then we're going to draw a or arc. We just need the part that cuts through the circle right there. That's all we need. Okay? Now, part two of the rules, the directions say, label the endpoint of the ray as C. So I'm going to put a C where that ray started, and where the circle C intersected the ray, I'm going to label this as D. So this is now segment CD. So far, so good? Okay. What if I wanted to double the length of the segment? Because that's what it says to do below, right? For the next one, to draw this twice as big. How can I use my compass to keep going and make one that's twice as big? I want to say Claire. Claire? Good. Now just move the sharp point over to D and draw another arc, right? And where that arc crosses through the line, now this point, if we call it E, is twice as big. CE is twice as big as AB. Okay, question time. How do we know that CD is the same length as AB? I'm drawing the circle in because we're going to talk about it, right? How do we know that this is the same length? Number one, when we measured AB, we drew a circle, right? Okay. Then, when I made my segment over here, I drew a circle. What part of the circle are AB and CD? What part of the circle are AB and CD? There we go. What's the name of that line vocab? The radius. Now, are those circles the same thing? Are they congruent? Are they equal? How do we know they're equal? Someone? Yeah, we measured them and drew the same compass line. Okay? So if they're the same circle, do the radii have to also be the same? And that's how we know that these are equal, because they're radii of congruent circles. Okay? And that's how we know that this is double, because it's also a radius. Make sense? And that's our justification. So what I'd like you guys to do down below is to double the length and triple the length of AB. What I would recommend for this one is when you start, just draw yourself a segment that kind of is at a little bit of an angle here. All right? And then go ahead and measure AB and double and triple it. If you notice that your segment or your arc goes beyond your segment, what should you do? What if your third arc is over here somewhere? Yeah, just extend the line out. So make the line long, okay? All right, let's see it. This, okay? So we had a line segment, we measured AB from the end point there, we did 2 arcs and slid our compass up, and we doubled that length. Now the cheat code that some people noticed was when they wanted to double a segment length, and they had this line here, all they did was pick a point in the middle, say here, and then they just drew a circle. And as long as you know where the middle is, right, this side is a radius and that's a radius, so they're automatically double. So kind of an interesting way to think about that one. But, all right, so once again, measured AB, start from the end point over here, 1 arc, slide your compass up to the second one. So we drew 1, 2, we got it. Here we're doing 3 times as big. So measure, slide up the way, mark off your arc, and you're good to go. Questions? All right. Okay, on the next page, we want to copy a triangle. So the only thing we need to do to copy a triangle is we need to copy the sides, okay? So far, so good? So they already gave us a ray or a line segment next to it to use, all right, for one of the sides. So what we need to do is measure the lengths of the sides here so that we can copy it. So how do we, Christian, how do we copy our first segment? Okay, good. Well, we're going to do one at a time. So we have to start by putting our sharp point, you said, at A, and then the pencil at C. Okay? We can always mark a little bit of an arc here to show people that we've measured it. Don't have to, but you can. And then we're going to slide our compass over to the end point here. I think we'll label this one P. So we're going to draw a circle around P. Do we need the whole circle? Nope, just the arc that cuts through that line. And where this hits, we're going to call this, well, it's set up here to label the endpoints of, so we'll call this one Q. So we know that AC and PQ are congruent. So far, so good. Step 2. Now we got to copy segment AB. So sharp point goes back on, pencil goes on, okay? Now look where point AB is. It's somewhere up in this area, correct? So I'm just going to draw, when I draw my arc, I'm going to draw it somewhere in here. So first thing I can do if you want to is draw yourself a little arc just so you see where that is. Slide your compass over to P, and I'm going to make an arc. I don't know where exactly, but I just want to draw a little bit bigger arc somewhere in this area because I know that's where this point should be, somewhere up here. Does that make sense so far? If you kept going, you'll get another part down here, but we just want the part that's up top. So far, so good? Now we need to measure. So we're going to put our sharp point on, pencil on, okay? So sharp point on C, pencil on B. And you'll notice when I draw my arc on the original figure, I kind of create this X here, right? That X is where the point B goes, right where the intersection of those two circles or arcs is. So when the next step I do is place my sharp point instead of on C, but on Q, good. And then I'm going to draw an arc that goes through and makes an X, right? With the circle we drew around P with this arc, right? That was from the first step. So draw another arc. So X marks the spot here. And right where those two arcs cross, that's going to be point R. And because we have to make a triangle, now we just have to use our straight edge and draw the lines in. Now, this ruler on the board is super annoying to use and hard to get it right. So if you see me just making straight lines, it's because it's very tedious to do this. Because when you turn one part, the other part moves. But there you go. And we are done. All right? Questions? Okay. So what I want you to do for homework tonight, and you guys can do this coming in first thing tomorrow, okay, is on page, it's on the board up there, on page 13, I want you to do number 7. Okay? 13, number 7, and 14, number 3. Tomorrow we're going to take a look at how to make an equilateral triangle. So I'm not going to have you do that one yet. Just those two. I know the front of your packet says page 14, but changing the homework for you. Okay? So 13, number 7, 14, number 3. All right, make sure on the way out you drop your rulers and compasses back over in the box over there, and then the container. You guys are out of here in a minute. We have a great day, and we'll see you tomorrow.